API integrations at your workplace or in your personal projects, and you're asking yourself if there is a better way to do stuff, right? So theoretically, I'm going to be showing you a better way to do stuff. If you think my way is not better, please, you can tell me. I'm not going to be afraid, I'm not going to be angry. Yes, I will tell you not to tweet at me for a while, I ban you on Twitter, but that's going to be the end of it. So the point is, whatever discussion we have, you can question the assumptions that I have. You can ask questions about things that are not clear, and you can also see me and say, hey, guy, that thing that you cooked is beans, and I don't like it. So everything is allowed. So let's go very quickly. My name is Simi Oluwatomi, and I just like to call myself a senior software developer. In fact, left to me, I'll just call myself a software developer because that is what I do. I have been programming now for about 9 years. I've been doing this professionally since about 2018. So I think I know a thing or two, right? My name is Simi Oluwatomi everywhere. So you are not going to see me on Twitter at something like Simi Oluwatomi for real at yahoo.com. No. I am Simi Oluwatomi everywhere. On Gmail, I am Simi Oluwatomi. On Facebook, I am Simi Oluwatomi. On LinkedIn, I am Simi Oluwatomi. And my website is also simioluwatomi.com. Now, what is the chaos that we are really trying to avoid? The first that I have seen over the years is a tight coupling between your application and the third-party API you are integrating with. And for some people, that coupling can be small. For some applications, that coupling can be like a marriage. Let me put it like that. For instance, I have seen applications that model their objects or their database, maybe relational database, their database tables, or even MongoDB collections, after what the third-party API is telling them. So what happens is that the day they change vendors, all that data structure becomes what? It becomes nonsense, it becomes redundant. So that is a tight coupling. For some people, it is that there are no clear contracts, right? When I say contracts, I don't mean the contracts that everybody brings pen and paper to sign. I mean, there is no clear contract between what is yours, your responsibility, and what is the responsibility of the API you are integrating with. For some, there is poor test coverage around the integration. I remember many years ago, when I was starting out, I went to a company. I won't tell you their name so that you don't go and ask. I went to a company on physical test in their office, and the test was integrate Paystack API and write tests. I didn't write anything. I didn't even write the integration. I would like. That day I knew that I had lost that job. The challenge that I had wasn't that I couldn't do API integrations. The challenge was that I didn't know how to test the integration, and that threw me totally off. That I just closed my laptop and waited for 2 hours to be complete. What are the chaos that a lot of people experience? Retries. If the API request fails, that is the end. Sometimes people have problems with timeouts, especially when you are working, if you have done API integration with banks, you will not understand what I'm talking about. There's a timeout where if your client does not connect to the third party in about 1 second, that is the end, right? Sometimes there is no fallback. What do I mean by a fallback? Many of us do integrations and you are integrating with just one client. If that client goes down, your business goes down, or your application goes down, right? How do you do fallbacks? These are some of the things we are going to be looking at. For a lot of people, it is observability. Like, you don't know the request that went out to the third party, you don't know the response that you received. The only thing that you know is that the API request was successful or that it failed, right? If you are building financial applications and you don't have observability in your third-party APIs, money is going to miss. Believe me, I have been there. I can tell you for free. What are the issues? Vibe coding. Many developers have forgotten that there are things that are called what? API keys. So even in 2025, people are still leaving their secret keys inside where? Inside GitHub. Right? So you wake up one day and you discover that your AWS account, you now have a $10,000 bill. And you are wondering, how did I get here? You got there because your keys were what? Your keys were in GitHub. Now, how do we go from all of the things that I have just mentioned to a place where you can sleep well at night knowing that things just work? And I talk about this as, I term this the clarity framework. This is how I think about third-party APIs. And the first place I start from is standardizing things very early, right? I want to standardize things very early because maybe because of the kind of applications I have built, from day one, when you are doing an integration, you already know that in the next 2 months, there's going to be a fallback provider for whatever you are doing. So if you don't start the standards early, when that second third-party provider comes in, you begin to make very costly mistakes. The second thing is that I like to decouple things. And many times there is this battle we keep fighting. Abstractions over keeping it simple, stupid, right? What is the right level of abstraction that you need to have? At what point do you keep things extremely simple, right? The third things are designing for failure, because believe me, even AWS does not have 100% uptime. No service, any service provider that tells you in 2025 that they are going to be available 100% all year round, 365 days a year, they are lying to you. Even if that's what they told your boss or your PM or your business analyst, they are lying. Something is going to happen. Something is going to break. You have to plan for it. The next thing is testing. We are going to look at testing. What do you test? How do you do the test? And then the last thing we are going to look at is monitoring. So these are the things that I would like us to cover one after the other, and hopefully at the end of everything, we should have a very good idea. We should be very clear about what API integrations should look like. Now, I like standardizing things early because defining your API integration standards before you have 15 different ways to do different things. And that's particularly important because the way I want to solve a problem is different from the way he wants to solve the same problem. The problem starts when he has a ticket, I also have a ticket. I do my work, he does his work. And then at the end of the day, imagine not just the two of us, imagine in a team of 7.
Thank you.
Right? At the end of the day, you start reading the code base and you discover that everybody has done things the way they like. And when everybody does things the way they like, what you end up with is what? It's chaos. And that's why even societies have laws, because if you trust people to use their common sense, you will discover that what? Common sense is actually not what? It's not common, right? Now, what are the things that you need to define very early? The first are contracts. I don't know the kind of organizations you work with, but one of the things I tell people, especially people who come to me and say, I want to work in fintech or I want to do fintech API integration, the first thing I always tell them is that everything you see on a vendor's website is negotiable. If a vendor tells you that how much they charge is 15 naira per transaction, depending on who is making those integrations, you can negotiate that 15 naira per transaction down to 30 naira.
That's basically
He does not want me to tell you because he works at a vendor, right? So everything you see on the website is negotiable. So in some cases, before you start the API integrations, your team needs to sign a contract with that vendor. Somebody has to sign on paper in that contract, you are going to define your SLAs. What is the percentage uptime that vendor is going to give you in a year? Because how do I say? They are giving you something other vendors can't, one way or the other. And because they are telling you that whatever reassurance they are giving you, they will stand by it. So if a vendor tells you that they are going to be available 80% of the time during the year, your own job is to ensure that they are actually available 80% of the time during the year. So if you do that API integration and you don't do your monitoring, you can't go back to that vendor and tell them that, oh, you were only available 70% of the time. Why? Because you didn't even know that they were not available. Am I communicating? Yes. So the first thing is that in some cases, you have to sign contracts, right? The second thing is that you have to talk about API depreciations. I was talking with some people earlier today, and we were talking about the dark days. When I say dark days, I mean 2016, 2017, 2018, where if you want to do an API integration, you send an email, and then they will send you a document. And in that document, the first 10 pages is just grammar. You can't even see the endpoint you want to call. I'm serious. It's just grammar, right? It's just grammar. And then at the end of the day, is the last 5 pages that just talks about the API you want to integrate, right? And then those last 5 pages won't even tell you that, oh, if a field is going to change in the next, if you are going to change from version 1 of this API to version 2, how long do we give you to do your upgrade? If you don't define those things very early, in some cases, it can end up biting you in the behind in the future. Now, what are those things that you also need to standardize? You need to standardize your responses, because imagine you are doing a paystack integration and then you do a Flutterwave integration. Both vendors have different responses. How do you marry both responses into your own application? You have to standardize something, right? So it is at the beginning that you should do for your responses, right? You should do for your responses. You should also look at your error formats. This is a place where many people don't even think about. Vendor A sends you response code 01. How many of us have worked with Twitter's API before? You see very weird things. There's an internal error, there's an internal message. Then they have the status code, the HTTP status code. Then they have another code. And then you either have to go somewhere to now read what those codes means. Now imagine you are doing that, as you are doing the Twitter integration, you are also integrating another third party that has a separate error response format. Something has to marry one response format to the other response format, such that your application can deal with all those errors in the same predictable way. Right? Number 4 is pagination. Imagine, I like using fintech a lot because I built in fintech for about 6 or 7 years. Imagine close of business, you want to do your reconciliation. You get all your transactions of the day from Paystack. And then you go and get all your transactions for the day from vendor B. Vendor A uses offset-based pagination. Vendor B uses cursor-based pagination. How does your application paginate both APIs? If you have not been there, you have not been there. If you have been there before, you know that it's a big headache. Those are things that you need to sort out extremely early. Next slide. Decoupling for scale. So the standardization is just things that you need to think about. Decoupling for scale for a lot of us that are engineers is where you probably write a lot of things, right? Now, build abstractions that let you swap, scale, and evolve your API integrations without rewriting your entire application. Some years back, a particular API provider that an application I was leading was using announced on a Sunday morning that their partnership with one of their key partners had ended. I was in church. My manager called me, Simi, are you on Twitter? I said, no, I'm in church. Then he said, go and check Twitter. I went on Twitter. From Twitter, I was on a 2-hour phone call. From that 2-hour phone call, I left church, got back home, and worked till Tuesday. What was the problem? We were using that vendor for inflows. When they announced that partnership had been cancelled, our customers could not receive money. We were using another partner to send money. So our customers could not receive money, but they could send money. Have you seen the disaster yet? What is going to happen? By Monday morning, accounts are going to be calling you. Because what is going to happen? Float is going to run out. If your company runs out of float in fintech, you are what? You are dead. Guess what? A year later, I was talking to someone that has now become my boss. And he told me that that same news that I received that day, he was on a flight to the US and he had to code throughout that entire flight. What was the problem? Company. That was the problem. If your vendor does an announcement today that will cause your developers to have to work for the next 3-4 days non-stop to get a critical part of your application running, you have made bad decisions. And that's just the truth. I have been there before. So, what are these abstractions that we need to build? So, this is a typical request flow. In many applications, a request comes into your system, and for how many of us right here write Node.js or JavaScript or something? Oh, okay. In your controller, you create an instance of Axios, and you just make the request. If you are in my team and you do that, that PR cannot pass peer review. In fact, it's so bad that people will do a try catch inside the controller there. You people know what I'm saying because you have done it before. Right? So the first problem in that application is that there is no SDK. The API you have access to is chaos. You don't need to know the programming language that API is built with. But at the minimum, you should be using an SDK. I'm not saying you should go and install a package. I'm saying use what? An SDK. And I was telling someone this morning that API integrations, you can wake me up and I'll do API integrations because usually I just write my SDKs myself. Don't come and meet me to write SDK for money, please. Right? So you can install a package or write your own internal SDKs. What you want to do is that every API request that goes out from your application goes from one central place. Right? Now, the next thing we are seeing there is that there's a service. So the controller is a traffic police. When the request comes, if the data is bad, it sends the response and all of that. The service is more like, how many of us watch Superman here? Yeah, that service is Brainiac. How many of us know Brainiac? It has the brains, it has devoured multiple planets, it knows everything. That is what our service actually is. If you have business logic in your controllers, you are doing something wrong. Your controllers should only receive a request and return a response. So whether you are using command handler, CQRS, this one, that one, there is a place where it's the brain of your application. That is where things should start kicking in. Now, there's something there that I wrote, a selector. I may not have named it properly, but I'm going to explain what it does. It's basically a kingmaker. So let me give you a scenario. You have Monify, you have Paystack, you have Flutterwave. In Monify, you have 10 million. In Paystack, you have 1 million. in Flutterwave you have 200,000. A customer wants to send 5 million. Who needs to handle that request? Because you can't transfer 200,000 from Flutterwave, then transfer 100,000 from Monify, and then balance it up and tell your customer to tell who they are sending money to that we went to gather the money together. It is not a job, you know.
So Simi, in payments, your selector is a switch.
Yeah. So your selector determines where that request should go to. So if you have a circuit breaker, that is where your circuit breaker is going to be. I'm going to explain what the circuit breaker is. So the selector is practically the kingmaker. It's the selector that says, this is the third party that is going to service this particular request and orchestrates things going forward. Then there's a provider. Now, if your application is extremely simple, you don't need a selector. If you have not integrated 2 or more APIs, you don't need a selector. You can just call a provider. Now, what is a provider? I'm going to explain what it typically does. We have said we want to standardize responses, pagination. If you are fetching list of banks, you don't want to call Paystack every time to get your list of banks, right? That is what your provider does. It provides caching, it standardizes responses, it does data transformations, DTOs, that is where they live. Your SDK is where your API requests actually go out from, right? So that is where you configure your authentication and all of that. And then the API is just there in the wild. If you have something that is very different from this, or if you're already doing all of this in one way or the other, then you are safe. If you are not, and tomorrow your boss comes with a new API, you may have problems. Next slide, please. Designing for failure. Assume that everything is going to break. Now, the first thing that you want to ideally have is a circuit breaker. So what your circuit breaker does is that it cuts power when things go wrong. If a vendor tells you they are down, you don't need to continue sending requests to them, right? So that's what a circuit breaker does. The next thing is a smart retry. You need to have smart retries. Somebody sent money. The API told you that they are processing it. How do you continue to get the status of that particular transaction? Tip, don't just retry every 2 minutes. Do something like an exponential backup. It's very easy to write, no matter the programming language you are dealing with. Just Google exponential backup. You don't need to be smart. Don't worry, you are going to see algorithms for it. Next is backup plans. Have plan A, B, C, D, E, F. Right? So your plan B would most likely be your cache. For data fetching requests, you can do some smart caching. Right? So if the API is down, you just serve that data from where? From your cache, right? You can have multiple vendors that do the same thing. If vendor A is down, vendor B will be what? Will be available, right? If both A and B are down, have vendor C, right? That's the only way you can stay at the top of your game. And then the final part for designing for failure is graceful degradation. It is better for part of your application to be working than for all of it not to work. So you want to build your system in such a way that you can turn features on and off, because some outages affect everybody. If NIPS is down, maybe only OP or PanPay will receive money. Every other person, there's nothing you can do. So in that kind of scenario, you should be able to shut down a part of the application and say, I don't want people to send money because NIPS is down, right? But people can receive money. Do you get what I'm trying to say? So that is designing for failure. Every integration is going to fail. You need to do what? You need to plan for it. Now, testing. I'm going to go through this very quickly. I'm going to start from the base of the pyramid. You need to have unit tests, end-to-end tests, chaos tests, and integration tests. Your unit tests are going to mock your API responses, right? You are just going to give a JSON output and it's going to run. Your end-to-end tests are going to mimic what your production environment will look like. Most likely, in most places, this is what your QA engineer is going to do. Your chaos test is production. It's actually production. If you can't take your chaos testing environment to production, you have a problem. Your chaos testing is what should resemble production as much as possible. And then your integration tests are tests that verify your API interactions. I have something more here, but I'm just going to, the time is up, right? So the slides are going to be made available to everybody. If you want to catch me for a question, I'm available. If you have any questions, can I see your hands? Okay. Somebody has a question. Just a question.
Very much, Mr. Simi. So I wanted to ask if you could share some smart try strategies. So speaking practically, in Nigeria fintech, for example, let's say I have 4 providers and I have one primary provider that I trust. Now I've made 5 requests to my provider and then all 5 have failed. Now I know that my provider has a problem and I have to switch. Is there a solution you can recommend where I don't have 5 customers suffering before I recognize that this provider is having an issue?
Okay, that is what your circuit breaker is actually supposed to do. Because the way circuit breakers are designed is that when requests to that provider are failing, it switches on the circuit. Circuits are not the way we think. When a circuit is closed, that is when it is on. When it is open, it is off. So your circuit breaker has to go between closed, half open, and open. So when requests to a provider are failing, it should go to half open. If after a specific time period it continues to fail, it should go to open. When it goes to open, anything that comes in, it just rejects. That's what your selector will do. It will confirm from your circuit breaker. Now, sometimes you just have to go to Slack or Teams or Skype to go and shout on them. I have done this before. It works. They should fear you. If they don't fear you, these people have to fear you. So sometimes you just have to go to Slack or email and go and shout on people and then query the status manually. Yeah, thank you. Thank you very much.